We're all seeing AI just explode, right? It's changing pretty much everything, how we work, how we live. But that power, it comes with this growing question mark about its energy use. I mean, huge demands. So the big question is, could this game-changing tech actually somehow be part of the solution? Could it even offset its own footprint? Today, we're doing a deep dive into some new analysis from PwC. There's this really compelling report they put out back in April 2025. And the title basically asks the question right out, could net zero AI become a reality? It's a huge question. And honestly, the report offers a bit of a surprising perspective. So our mission here is to unpack what this report says. Look at the energy challenge AI poses, but also explore these unexpected ways it might be a solution. We want to get our heads around what it would actually take for AI to hit neutral or maybe even, positive impact on global energy and emissions. This is really for you if you're curious and want to get the big picture of the key details without getting lost in all the technical stuff. Okay, so to really get this paradox, we need to start with the reality right now.
The sheer scale of AI's energy footprint. We know these models are boosting productivity, driving innovation. But what's the actual tangible hit on our energy systems today?
Yeah, the current picture is pretty stark, actually. There's this global boom in building data centers, and a lot of that is driven by AI. It's putting a real and definitely growing strain on energy grids. Just to give you a sense of the scale, the International Energy Agency, the IEA, they project that by 2026, data centers worldwide, and that includes the AI stuff, could be using as much electricity as Japan.
The entire country of Japan.
The whole country. Yeah, it really puts it in perspective. And to meet that demand, you're seeing enormous investment, billions. Tech giants, investors, energy companies, they're all pouring money into new generation capacity. The tricky part is sometimes that means relying on fossil fuels, though, sometimes it's pushing nuclear investment too. And what's really striking, kind of a dilemma, is that even the big tech players, the ones with really ambitious goals for cutting carbon, they've admitted that running AI at scale has actually made their own emissions jump up. It's a clear conflict,
That really does lay out the tension, doesn't it?
Yeah.
It feels like AI is supposed to be about efficiency, optimization, but the infrastructure itself just eats up so much power.
Right.
Where's the way out of this? Is there another side to the story?
Oh, absolutely there is. And it's just as true. AI also enables some incredibly powerful sustainability tools, especially around energy efficiency across the rest of the economy. That's the counterbalance we really need to focus on, too. Think about some concrete examples. There was this report involving PwC Germany, Microsoft, and Oxford University. They highlighted things like AI predicting when rooms get hot and pre-cooling them automatically, optimizing building energy, or finding much better routes for cargo ships and commercial planes, cutting down fuel use significantly. Even in heavy industry, like cement manufacturing, which is super energy intensive, AI is helping refine the processes, the materials.
Okay, right. So you've got AI needing more juice in the data centers, but then it's also got this knack for finding savings outside those data centers.
Sure.
So the huge question, the one the PwC report tackles, is could those savings actually balance out the extra demand? Could it really compensate? Seems almost, too neat.
That's exactly what PwC dug into. And yeah, their findings are pretty fascinating. They didn't just theorize, they actually built a model, a pretty sophisticated one. It simulated AI's effect on energy demand in two places, inside data centers and then, everywhere else in the economy. And the core finding, the really central takeaway is this. Their model suggests that if AI improves energy efficiency across the wider economy at just 1/10 the rate it's being adopted, then it could pretty much make up for the extra energy the data centers need. What that boils down to is AI's overall effect on energy use and emissions could actually be neutral.
Neutral, wow.
Yeah, which kind of flips the script, right? From AI just being an energy problem to potentially being, part of the solution if, and it's a big if, we deploy it smartly.
That's a really powerful if, but it points to huge potential. I'm really curious how they got to that number. Let's break down their calculation. First, powering the AI itself, the infrastructure. How much more energy are we actually talking about for data centers?
Good place to start. Yeah, the vast majority of energy use for AI happens right there in the data centers. It's the chips, the hardware, doing all the heavy lifting for training the models, running the computations, and the investment numbers are just huge. Like Microsoft alone is planning something like US $80 billion for data centers in fiscal 2025.
$80 billion, just one company, 1 year.
Yep. So PwC's modeling, based on widespread AI use, Projects may be 13 to 16% more energy use in data centers by 2035 compared to if we didn't have this AI boom. And looking cumulatively, like over the whole period from 2024 to 2035, total energy use in data centers could be 18 to 21% higher because of AI. But it's not all bad news inside the data centers themselves. There are efforts underway. There's some hope. You see reports about companies like DeepSeek, a Chinese startup, working on more economical AI tools, more efficient ones. And there's a ton of research going into better chips, more efficient silicon, and also smarter ways to cool these centers. That could definitely help bend the curve a bit.
Okay, so that's the demand side. It's significant, clearly, but maybe some engineering can shave off the edges. But the real potential game changer seems to be outside the data center walls. The savings AI can find elsewhere. Where are the big wins there? How much efficiency can AI realistically drive across the whole economy?
Right, the savings side. It's becoming clear that companies are definitely jumping on AI for energy efficiency. And not just because it's good for the planet, but because, well, it saves money and cuts carbon. Direct bottom line benefits. You see examples like AI automatically tweaking how electric vehicles charge to help the grid, or fine-tuning manufacturing processes with incredible precision to cut waste and energy. And the investment money is following too. Look at venture capital funding for climate tech startups using AI. In just the first 9 months of 2024, they raised about US $6 billion.
$6 billion.
Yeah, which is actually $1 billion more than they raised in all of 2023. So the momentum is there. Now, PwC's key assumption in their model, this is crucial for that net zero finding, is that for every 1% increase in AI adoption across the economy, you get a 1.1% improvement in energy efficiency outside of data centers, that 1/10 ratio we talked about.
Okay, so a 10-to-1 relationship between adoption and efficiency gains.
Exactly. And based on how they see AI adoption growing, that could mean 0.3% to maybe 1.3% less energy used outside data centers by 2035. And again, cumulatively, over that 2024-2035 period, the total energy savings outside data centers could be somewhere between 0.1% and 1.0%.
Right, so now we put the two pieces together. The higher demand in data centers may be 18-21% higher cumulatively, and these potential savings elsewhere may be up to 1% cumulatively. How does that net out? What's the final tally on the energy bill?
So when PwC crunched the numbers, netted out those effects, the results were pretty striking. Looking just at the year 2035, the net effect across the whole economy could actually be a reduction in energy use, somewhere between 0.5% and 1.1%, depending on the scenario.
A net reduction, even with the data centers.
Potentially, yes. And over the whole cumulative period, 2024 to 2035, the total energy use could range from a reduction of 0.9% at the optimistic end to maybe a tiny increase of 0.1% at the other end. But the key point is the extra energy used by the data centers would be roughly canceled out, offset by the savings AI drives elsewhere. It's this really fascinating balancing act.
That is fascinating. And if the energy use roughly balances out, what does that imply for climate change? For greenhouse gas emissions specifically?
Well, the flow-through effect on emissions is also quite positive in their projections. Widespread AI adoption, according to the model, could cut total greenhouse gas emissions over that 2024-2035 period by about 0.1% to 1.1%. And if you look just at the year 2035, emissions could be 0.3% to almost 1.9% lower with widespread AI compared to a baseline without it. So it really underscores the potential AI has not just for energy, but for direct climate benefits too.
This is quite a vision, a powerful potential outcome. But like you said, it hinges on that if. It's not automatic. It relies on companies making the right choices, deploying AI strategically. So if that's the promise, what are the practical things companies can actually do to help make sure AI lives up to this potential? How do they get this AI energy equation right?
Yeah, that's the crucial next step. PwC actually lays out 4 key actions for companies. First, and maybe the most obvious one, is use AI itself as a demand-side energy solution. Basically, use AI to manage your own energy demand better. It saves costs, it cuts emissions, win-win. There's other research from the World Economic Forum and PwC suggesting companies could save something like US $2 trillion a year by 2030 just by using technologies already available.
$2 trillion a year.
Globally, yeah. And as our energy systems get more digital, there's just more data for AI to work with, finding even more savings. Second key action, track the emissions of your own AI program. This is important. If you're using AI in the cloud, which most companies are, this mostly falls under Scope 3 emissions, the indirect ones from your provider's data center.
Right, the ones that are harder to see sometimes.
Exactly. But the good news is the major cloud providers are starting to offer emissions trackers. These tools can really help IT teams, sustainability teams actually see the environmental cost and then work to reduce it. Third point, Right-size your AI for the business need. This one's about efficiency within AI itself. Bigger isn't always better. Those huge models, like the large language models everyone talks about, they often cost more and definitely use more energy than smaller, more focused models designed for a specific task. Yeah, the analogy they use is pretty good. It's like driving a big, heavy off-road truck for city errands when a small, efficient car would work perfectly. Choosing the right tool for the job saves money and avoids needless emissions. And finally, the fourth action. Consider sustainability when you're choosing your AI vendors. Now, this can be tricky because, honestly, providers don't always publish detailed energy data or use standard metrics. It's still evolving.
So how do you judge them?
You look for vendors that do disclose their overall sustainability efforts. Are they optimizing their algorithms, using efficient hardware? Crucially, are they powering their data centers with renewables as much as possible, including for backup power? Look for that transparency and commitment.
Okay, 4 key actions. Use AI for demand savings, track your AI's emissions, right-size your models, and pick sustainable vendors. That seems like a solid framework. So pulling all this back together then, what's the core message for you listening to this deep dive?
I think the main takeaway is really this. The PwC analysis shows AI has this remarkable, maybe even surprising, potential to reach net zero impact on energy and emissions. It could even become a net positive for sustainability. But, and this is the key point, it's not automatic. It won't just happen on its own. It really demands deliberate choices, strategic action from all the companies developing and using this technology. It's a potential we have to actively unlock.
It's a potential, not a guarantee. And that leads to maybe one final thought to leave you with.
Yeah.
If AI's ability to drive efficiency is potentially so powerful it could offset its own significant energy use, what else could it do? What does that imply about the broader role AI could play?
Right.
In tackling other huge global challenges, way beyond just energy, it really challenges us to think not just about what AI can do, but maybe more importantly, how we consciously choose to wield that power for a more sustainable future, something to mull over.